Hello, everyone, and welcome to my presentation here at the Full Stack Actuarial Conference called Making Workbooks Work, Performance Optimization within Excel. My name is Jeff Sanyu. I'm a Vice President of Actual Transformation at Empower, and today I want to walk you through some of the elements of Excel workbooks that might make them not work as well as you'd like. Maybe suggest some better tools to use in those cases, or ways to clean up those workbooks so that they're functioning the way that you always kind of wanted them to. I'm going to go back and forth a bit here between the PowerPoint presentation and Excel. So I'm going to have the PowerPoint, not the full screen slideshow view, just the normal view. We can go back and forth, and I'll walk through some of the issues that I've seen with Excel and things we can do to make it operate better. So with that, I will share my slides. To start, I want to make sure I emphasize our antitrust policy. If you feel like there are, please review this page. If you feel like there are any things that are being said which would violate antitrust laws and regulations, please leave and alert the necessary authorities. I'd also like to make sure that we thank our sponsors for this conference, the Standard, Coherent, Gunter Group, and Posit. Their support is critical to making sure that initiatives like this can succeed. And I'm really glad that they're able to provide the support that we need to pull off events such as this. A lot of great information over the course of today you'll be learning. And thanks again to these sponsors for making that possible. Please remember the views and opinions expressed in these sessions are mine and do not necessarily reflect the views or positions of my employer, Full Stack Actuarial, conference sponsors, or any other entity that I may be associated with. All right, let's dive right in. So I think most of us are familiar with Excel. If you're not, you're probably in the wrong session. But I want to start off a little bit by just reflecting on why and how we use Excel. I think we're just so used to using it all the time. We may not have asked ourselves those questions. Why am I using Excel for this particular purpose? And I think the first reason why most of us use Excel is because it really is the fabric of modern financial reporting. Every company I've ever been in has had Microsoft Office and Excel on there. It's not just an actuarial platform. It's used by the finance area. It's used by new business. It's used by sales. It's used by every part of the company. There are no restrictions on having Excel generally. And everyone has the same permissions to be able to make workbooks in Excel and share them. Excel also allows very quick prototyping. You can say, I want to do a 10-year term life policy and just see what the reserves would be. You whip up in a spreadsheet in a couple of minutes. Doing that in a more robust computational platform might take considerably more time. So Excel really does excel at being able to prototype things very quickly. Excel is also used a lot for many different things. So you can use Excel to document something. You can use Excel to do calculations. You can use it to put together some charts or tables or graphs. Or you can use it for code. Like Excel allows you to do all those things just in its base functionality without requiring too much additional work or plugins or libraries in order to get those things to work. I mentioned at the front that almost everyone has access to Excel. And one of the features of Excel that I think a lot of people have used being very powerful is the ability to easily link data together. Having one workbook that you get from finance, having a workbook you get from risk, having a workbook you get from actuarial, you can bring all that information together into one source and then use that for your reporting. In terms of how we use Excel, and this is by no means an exhaustive list, just my own personal experience, use Excel for data entry and storage, being able to put a couple thousand rows of data someplace. Excel is a great place for that. Being able to perform calculations, anything from a simple addition, like I have my money spreadsheet in Excel, so I keep track of my balances and all my accounts. or very complex. I've seen, some pretty sophisticated modeling being done in Excel using just native functionality there. We can use Excel to do comparisons between data, using things like index match or lookups. We can do analysis, being able to take information, break it into buckets, and then pull it together into some sort of analysis you're trying to put together. I mentioned modeling and projections as well. Planning and prototyping. I talked about how Excel is very quick at being able to allow you to prototype things. And that really does make Excel almost an ideal tool for doing prototyping. If you want to try and plan out, here's what we want to try and do in our model, it helps to be able to have a prototype for that built out first. And Excel is a great tool for that. And then when you're building your model in your modeling software, you can use that Excel prototype to be able to check to make sure your calculations are going the way that you would expect them to. I often use Excel as a shell for code and automation. So, for example, if I need to do something in a database and I have 100 fields, they're called value 000 to value 100, and I want to put up a value in each one of them, I generally tend to use Excel's features to create the text I would put into that database to do that data insert. So it really helps in that regard. Or using VBA or other tools to pull data from different sources and bring them together into kind of one holistic presentation. And speaking of presentations, Excel has native charts, native tables. It's something which you can put together without having to know a whole lot about how to code these things. You can use Excel's native features to be able to put together quick graphs that really convey the message that you're trying to present to your management. But just as Excel has a lot of great uses, great reasons why we use it, I'd say we also tend to misuse Excel. And I'm guilty of this as much as anyone. So let's take a few moments to talk about why we misuse Excel and how we do that. So one of the first reasons, and one of the main reasons that I've seen is, at least for actuaries, is ego. It's, well, I can do that in Excel. I know how to do that. So no matter what problem comes along, I can do it in Excel, and so you do it in Excel. Other times, you may not be familiar with other tools that are available to manage some tasks. It may be those tools, you don't know about them, or maybe they're not available to you because of some IT restriction. I've been at some businesses where in order to have a SQL database put in place, that was basically a non-starter. The only thing you were able to do as an individual user was using tools like Excel to be able to store your data. Another reason why you might be misusing Excel is you just don't know how to optimize the performance within Excel. And hopefully this presentation gives you some tips that can help you out with those situations. And we get to the how do we misuse Excel. I'll give you some examples of like what that might look like. Another reason why we might misuse Excel is that we talked before about how prototyping is really quick in Excel. But going from that prototype to production is a step that maybe Excel isn't necessarily the best tool for. If someone has a request for something, you probably first think of, I'm just going to do this in Excel. You whip it up, it's quick and dirty. And then before you know it, it's part of a large production process. But because of your other demands, you don't really have time to go into Excel and kind of clean that up. So it's important to recognize that that does happen. And that might be a reason why people might misuse Excel. And the last one I'll mention here is that, because every area in the business uses Excel, you're probably involved in some process chain where your downstream users are asking you to provide an Excel file. So like no matter what you do in the meantime, they want you to provide an Excel file. And so that's why you might do a whole bunch of stuff in Excel because like, well, I have to present an Excel file to them anyway. I'll just code everything into Excel. Now, in terms of how we misuse Excel, here are just a few examples. The first one I think we're all kind of familiar with, seeing a workbook that is way too big. I've seen workbooks over 100 megabytes. They take minutes to open, and they crash in a moment's notice. That is not really what Excel should be doing. And we'll talk about some ways to kind of get around that in this presentation. Sometimes people, again, due to ego, often, want to try and have a single formula that does everything they need. So, 7 nested ifs or 35 different types of where clauses that are in there or if statements that are in there. I think everyone's kind of seen these sorts of situations where a very complex formula or calculation is trying to be done within one formula. You have to like drag down the Excel formula bar to see the whole thing. I mentioned before about how Excel can be used to link data from different sources together. And that is a feature, but it's also a curse. I feel like oftentimes linking is done as well, I'll just get the data that I need right now. And they really don't think much of it after that. But you have to realize that the workbook you're linking to or from, that can change over time. You might have new rows and columns that are entered. And if you're just linking workbooks without thinking about the meaning behind that, then you're reliant upon or you're subject to issues that might come when those upstream files change. Sometimes people will try to do pretty fancy formulas in Excel and use what are referred to as volatile functions. We'll talk about that a bit more in this presentation, which can really slow down your performance in Excel. And last one I touched on a little briefly before, going from prototype to production without cleanup is one way we misuse Excel. It's going from something which works for now and trying to say it'll work forever without going through all the necessary cleanup work associated with making sure that it's robust and it will be persistent. So with that, I want to get into what I've seen are the top reasons why workbooks just don't work. I've kind of broken this up into a couple different sections here. The first category are what I call the major offenders. These are having linked files, files that are very large, overly complex formulas, volatile functions and tables. We can have volatile code and ranges as well, including like dynamic ranges. Then we get into some of the more pernicious things that are a lot harder to diagnose. Worksheet level names is something which can cause some serious issues. And then I have a few obscurities in here as well. These are things which aren't as common as the ones above, but I have seen them a lot. And when I do see them, there isn't necessarily, it's a lot harder to diagnose that these are the issues why this file is not working right. The 3 examples I have here are having excessive linked names in a workbook, having a workbook where the blank rows and columns aren't being reset, which then causes extra size that shouldn't be there. And the last one is having compilation artifacts in VBA code. It's a real niche situation, but it's also something where if you don't know how to handle that, then your workbook is basically dead. All right, so let me start with what I view as being the #1 source of data issues I've seen in Excel, and that is linked files. I want to kind of differentiate here in my presentation between issues that present a performance issue, as in Excel runs slow, it's not responsive, it's taking too long to calculate things, and data integrity issues, where you have something in place which is harder to debug, or it's more fragile than it should be. So linked files really presents both of these risks. From a data integrity risk, when you link a cell from one workbook to another workbook, you're linking the position. You're saying, I want this workbook cell C5. not really passing on the meaning of what that's supposed to be. What happens then if you insert extra rows or columns or delete rows and columns? If you don't have your target workbook open at the same time you're making those changes in your source workbook, then you're going to get out of sync. You'll open up your target workbook at some point in the future. You'll see a number that's in there for your reserves and say, oh, well, it's linked from this other workbook. It must be right. But unfortunately, again, unless both the target and source are open at the same time, then those links don't automatically update if you move things around in your source workbook. Sometimes when you have a linked workbook, the file path for your source might become truncated. So I've seen situations you're referencing a network drive, and it might be 10 subfolders deep. Excuse me. And then all of a sudden, your target workbook drops off 3 of those levels. You don't see it, but now when you try and trace the link back, it says, I can't find this file. So in those cases, the links basically become worthless. They get destroyed. And the whole purpose of having the links goes away. I've seen a lot of occasions where people have a source workbook and a linked workbook, and their target workbook is doing large calculations on the source workbook. So example I have here, a sum ifs on the source workbook. This is not a great way to set up a formula here. It's going to really dog your performance significantly. Excel is really good about being able to add links to a file. It doesn't really clean them up though. So one of the issues you might see is that you might have a workbook with a lot of old links that are no longer relevant anymore. I'm sure if you try doing an extensive study of some of your evaluation or like year-end workbooks, you'll probably see a workbook from 2025, which has a link in there from like 2003. And the reason why it's in there is because it got copied over at some point, no longer relevant, but that link is still somewhere in that file. And then the worst cases that I've seen is people have linked files that are so intricate that they have basically an SOP written up for what spreadsheets they have to open in which order, and then how to close them in order to keep the integrity of the whole process, which is a very frustrating way to be doing your job. Okay, so I've talked a lot about the evils of linked files. What can we do to make them better? For starters, I would advise being able to store that information someplace besides Excel. So a database is my personal preference, if you have that available. And you have some way to pull that information in using code or Power Query, some way to get it without having to go to your links. The added advantage of that is that if you have a central database that all this information is contained in, that makes it so much easier to bring data from different areas together into these holistic dashboards, which are going to be more valuable for your management. If you're linking files or you're pulling information in, however we're getting it, I think it's also a good idea to keep a record in your target spreadsheet for when the data was pulled and where it came from. Personally, I try to avoid links wherever possible. I prefer to have queries or code set up to pull data from a known data source, and then when it gets pulled in, have a timestamp in the spreadsheet that says, here's where I pulled it from, here's where I pulled it. So every time you run it, you have that traceability of the information. Going back to the problem of doing these like sum ifs on ranges in other spreadsheets, please don't do that. It's way better to have your source file set up to do those calculations and have the output for those calculations stored someplace where the linking file can get to it, where you know that format is not going to change. Whether it's a separate tab on there called output, or just some way to indicate this is the data that we pulled together, and you're very confident that it's not going to be moved around at all. I also advise you to do a regular maintenance of your workbooks. Check the links. Make sure they're not still showing up if they are too old and that data is no longer relevant. The second issue that I've seen with Excel is massive file size. So for those of us who are old enough to remember, Excel used to have a limit on rows and columns, which was fairly reasonable. 65,000 rows, 250 columns. Well, in Excel 2007, they upgraded that to 1,000,000 rows and 16,000 columns. While you really couldn't use the old XLS format to do a database of any kind of size, with this change in the Excel's space, a lot of people said, "Oh, great! I can put all my information into an Excel tab and run it from there." And so there became more of a tendency to treat Excel like a database. One company I was at in the past, they had, for one of their lines of business, serial listings of people with several 100,000 rows and all in Excel workbooks. They had the money to have databases, but they were doing it all in Excel. I mentioned before that these large files really present a performance risk. So larger workbooks are much slower to open. They're slower to operate. You move around, they feel sluggish, and they're slower to save. That's just an example here. Let me try opening up a workbook I've got over here. So here is a 70 megabyte file. Actually, this one. That's a 92 megabyte file. See how long it takes to open. Now, this is on a network drive, so there's some network issues in here as well. Still going. Oh, still opening. Almost there. And stop. So that was basically a minute just to open this one file. Now, there's something really important in this file. This is just an example to show here. But working with workbooks like this is intolerable. It takes forever. It's not fun. And more importantly, they have a tendency to crash. And when they crash, then all your other open workbooks are wrecked as well. If you have auto recover on, if you have auto save on, then the amount of time it takes is greatly extended if the workbook is too big. So just in general, it's wise to avoid large files. I'd say personally, I'd say anything over 10 megs is probably too big to have in Excel, with some very rare exceptions. So let's talk about how we can try and overcome those file size issues. So one of the easiest ways to do this, and a way which is very strongly recommended in modeling circles, is to separate your data and your calculations from each other. So maybe you have if you're doing a model in Excel, maybe your inputs come from some CSV files, possibly massive files. Those can be 50 megabytes, sure, no problem. They get read into Excel. Excel does its calculations and sends the output to another file, which might be, 20, 30, 40 megabytes. The calculation engine itself is then pretty small, but all your data is being stored away from that Excel file. You can use code to manage that. One of the things that the code, at least with Excel, allows you to do is to store your data. Like Excel's worksheets they're fine for storing data from a presentation standpoint, from a calculation standpoint. If you're trying to do much more complicated calculations or much faster calculations, bringing the numbers in through arrays is way faster. Just working with those numbers in memory versus writing them to and from the spreadsheet. I mentioned before about storing data in a database. I think it's just a good practice overall to do. And then using Excel for other tasks besides just storing the data. One thing which can reduce the file size, but has some caveats to it, is using the XLSB file format. I go back to my folder here. I showed you this 92 megabyte file that I opened up. That's an XLSX extension. If I take that same file and save it as a binary format, XLSB file, I've cut off 20 megs of size. 20% of the size of that file is gone just by using this file format. Smaller files open faster, they save faster, they're a little bit sappier to work with, but the downside to that is that the XLSX, XLSM formats, these are XML-enabled workbooks. They can be read by many other programs, many other functions, applications. XLSB files, the B stands for binary, and Excel's binary format isn't necessarily readable by other programs. So one word of caution there, like if you have people who are opening things up on a web browser or linking to some other program, XLSB files might not be the right solution. And from a performance standpoint, while you're in the spreadsheet, one thing you can try doing is switching to manual calculations. That's more of I need to fix something right now, and I don't have time to fix the entire spreadsheet. That's when you would use this approach for a few reasons. The first is that it doesn't really solve the problem. It just kind of puts on hold for a while. And the second is that you're then much more likely to have issues if you forget that you're in manual calculations. You might be doing some code later on, which assumes your numbers are already automatically calculated, or you might be doing a spreadsheet presentation to someone and not realize the calculations are still manual. So caution advised on that. Right. What's the next way? The next biggest offender? I'd say overly complex formulas. And I want to make sure there's some nuance here. People don't always write very complex formulas because they are trying to, to be smarter than everyone else. Some people do. I'll not dispute there are some people who do that. But I think there's also some other reasons why people have very complex formulas. Some people will break up the formulas into various stages. You can see all the elements of the calculation along the way. Others will say, you know what? Let's just do it all in one fell swoop. Let's get a really complicated formula that does everything. And while that may use less space in Excel, it also has its own issues. The first one I'll say is just generally, the more complex a formula is, the more likely it is that it's going to be wrong. There's going to be something in there that isn't working the way that you're supposed to. When people write these formulas, it's often not really documented what it's supposed to be doing. They'll spend so much time debugging it, writing it out, trying again and again. When they get it in place, they don't necessarily say, okay, here's why the formula is the way it is. Here's what it's trying to do. And here's why we're doing it this way. That makes it much harder for someone to understand and debug that. And it's not just someone new who comes in. it's the original engineer as well can have difficulty in debugging a formula if they just haven't seen it in a while. Very complex formulas can also introduce a lot more processing required in Excel, especially if you're using user-defined functions. So these are things you put into like VBA code. And while Excel's base functions are very highly optimized, user-defined functions can be a little sloppy because the users don't necessarily follow the same tenets that Excel does in terms of like performance. And the last point I want to add here is that a complex formula might not just be because someone's trying to be fancy. It could be because you are looking at a spreadsheet that is 30 years old. And at the time it was written, Excel didn't have the functions that it has today. So some examples I have of this are like the SUMIFs function. There used to be a SUMIF, and that was it. So if you wanted to have the equivalent of a SUMIFs function, you'd have to use either a sum product calculation, and then make sure all your columns evaluate to numbers, or you'd have to take all your conditions you want to put together and run that into one condition that would then be used by your SUMIF. So just because you see a complex formula doesn't mean that someone was trying to be, really, really fancy there. It could just be because that was the only way you could do it when they were writing this in Excel. All right, so what can we do with some of these overly complex formulas? Well, I think there's always the balance you need to take between having the processing of Excel, like having the space to a reasonable amount of space, and the technicalities and the complexity at a reasonable level. So if you can break that formula into smaller pieces, each of which has a particular function, that will help you out in explainability and in debugging. Documenting what the formulas are doing and why they're written the way they are, that's always a good piece of advice. I talked before about using some more modern Excel functions. I mentioned SUMIFs. You can use the choose function instead of a whole bunch of ifs. There's like X batch, X lookup that are more recent, which if you're a relatively young actuary, you probably know. If you're older like I am, this might be news to you. These functions exist. So you can try evaluating these functions and say, what's the best way to handle this today, as opposed to what was the best way to handle this 20 years ago. Being able to have a regular review of your spreadsheets, or at least your key spreadsheets, to examine these formulas, that's always recommended, just part of your normal process, if you have the time to do that. The reason why I think these issues persist often is because we never do have that time. There's always more business demands that we need to be focusing on. And the last approach I have here is, if it's a very complex calculation, maybe you don't want to do that in an Excel spreadsheet. Maybe you do it in code somewhere. You do it in Python, you do it in SQL, you do it in some other program, or you do it in VBA code to make it a little bit more efficient. All these are options you can do for trying to break down these overly complex formulas. I mentioned links are my #1 pet peeve with Excel, is excessive linking. My #2 pet peeve are volatile functions. So for those who are not familiar, Excel has a series of functions, or a set of functions, that are referred to as volatile. And I've got them listed out here. These functions always calculate no matter what. So if you change a cell which is just text, it's not referenced anywhere else in the entire workbook, but somewhere else in your workbook you have an indirect function that recalculates. Normally, Excel has this, again, very optimized dependency tree that identifies, okay, for cell A5, it relies on cell A7, A10, A15. If any of those 3 cells change, then I need to recalculate A5. If it doesn't change, I don't need to worry about recalculating this. But the volatile functions always recalculate and can grind things down to a super slow halt. If you're using data tables and what if analysis, that's also volatile. It basically recalculates whenever you do anything in the spreadsheet. And if you're just trying to update a text field someplace, you have to wait 5 seconds for this data table to refresh, even though it has nothing whatsoever to do with what you updated. I want to point out conditional formatting is also volatile, and it can be referred to sometimes as super volatile because it refreshes whenever the screen is redrawn. So that can happen more times than just doing a calculation change. And part of the reason why volatile functions are so hideous or insidious is that they're generally copied over large ranges. So especially indirect and offset, those are functions where it's like, well, I want to reference a certain tab. So I'll use indirect and then the name of the tab. And then I'll have a cell range. I'll use indirect for that. And I'll use offset to add up, the 12 months in a year together. And then you just copy that formula over, 1,000 rows and 13 columns. So the more volatile functions you have, the worse this problem gets. Okay, so what can we do about volatile functions? For offset and indirect, really the best way to handle those is just get rid of them and replace them with index functions instead. Index used to be volatile, but unless you've been doing Excel for 30 years, you probably would never have experienced that. If you're using the cell or info functions, it's generally easier to have something in a code, like in VBA, to say what the information is. Basically, you run a procedure, it gets the information you need, puts in a cell statically, and then it's no longer volatile. For now and today, really just limiting that to one cell, as opposed to having that at every single tab you've got. And then you can use the other cells to reference that one. If you're using random, rand or rand between, then the way I've tended to do that is you write the function, you copy it over the range that you need, and then you do a copy, paste values, and kind of freezes those in place. Or have your code generate them using the random function there. If you're doing data tables, I'd say it might be better to loop that in code instead of having it just automatically refresh. Yes, whenever I see a workbook that is running really slow, this is one of the first things that I check for is, does it have volatile functions in there? Just like there are volatile functions, there also can be volatile code or dynamic named ranges. So one of the first tricks that I learned I thought was so fantastic when I was first learning Excel was having the concept of a dynamic named range. I have a range that's 10 cells big. I add something to row 11, and now my range is already updated to be 11 cells tall. The problem is that generally uses these same volatile functions. So the example I have here is if you have a range that is anywhere from, starting A1, anywhere from 1 to 50 rows, it'll look to find out how many rows are in there with anything that's has a value, and then use that to define your named range. But because it has that offset function, it's always going to recalculate over and over and over again. If you're doing VBA code, I've seen cases where the developer was trying to be, very, very special, put in some worksheet change events. You go into a workbook. If you select this cell, something happens, which sounds fantastic. It's great from a presentation standpoint. It is awful for performance. So if you have volatile applications, volatile functions, worksheet change events, then that's going to slow your spreadsheet down significantly. So again, really the same downsides as the volatile functions, but the reason why I'm spiking this out a little bit separately is because it's a lot harder to detect. So in order to understand that you have a volatile user-defined function, you need to actually go to VBA and find it. If you have a dynamic named range that's screwing up your spreadsheet, you have to go to the name manager and look for it there. And really, that's the only way we can deal with this stuff is to really go through the code, go through names, and see if we have potential issues. Another very pernicious issue in Excel is worksheet level names. So most of us are familiar with names in Excel. They help you to identify something, which you then refer to as a shortcut into your formulas. A lot of great uses for names. Having said that, Excel decided at some point that they wanted to have names that could be defined on a workbook level or a worksheet level. Like the example I'm showing here, we have a variable or a name called profit margin, but it means different things depending on what sheet you're on. So on sheet 2, it means 5%. On sheet 3, it means 6%. On the rest of the workbook, it means 4%. So this is something which has a very substantial data integrity risk if you have worksheet level names. So best approach to deal with these is just don't put them in at all in the first place. If you do have worksheet level names, then the first thing I recommend doing is check to see if the worksheet name and the workbook name have the same value. If so, get rid of the worksheet name entirely. If not, change your worksheet name into a different workbook level name. You may have some very rare situations where you do want to have different the same name meaning different things on different worksheets. If that's the case, please, please, please document them. Say they exist, here's what they are, here's why they're there. But I have not really seen good reasons for worksheet level names. So now back to over to some of the obscurities that I mentioned. I have a couple examples I'll show here in Excel. The first one here is having excessive linked names. So you might have a corporate template which gets filled out by a whole bunch of different groups, and it's been used over and over again for 5 years, 10 years. As that keeps progressing over and over and over time, those names get brought in, but they never really get brought out. And those names end up cluttering up the file, even if they're really no longer being referenced. So I have an example here where I have 2 spreadsheets. The first one has just links. And I've said before, I hate links. This is just an example of reserves and cash flows linking to a separate workbook. I have another workbook that has the exact same information in there. The formulas are the same. The presentation is the same. The first workbook is 81 kilobytes. The second one is 10 megabytes. Yeah, we're showing them side by side, or top to bottom here. Formula in the first workbook, formula in the second workbook, exactly the same. As I said, this second workbook is over 10 megs in size. And why is that? Well, I have something I put together into one of my add-ins that allows me to look at information within a workbook. So in this case, let's just get a list of a summary of this workbook, which will include all the names that are in there. And wouldn't you know it, the second workbook has over 1,000 names, and they're all linked names from another source. This is the only reason why these 2 workbooks are so big in size, are so different in size. So the 10 megabyte workbook just has 1,000 of these old legacy names that aren't being used. Close those back up. So the best way to really manage this is just doing periodic review of names in a file and removing those that are no longer applicable. I talked before about sometimes we'll have a file for 2025 valuation date, and you'll have links in there from like 1996, 1997, 1998. So clean those up. But as well, if you have names that are just reference errors, probably good to clean those up. One word of caution though, never get rid of a name that starts with _XLFN. These are used for compatibility with Excel. If you have pre-Excel 2007, again, probably not applicable to most people anymore, but it's a good idea just to keep those in there. My second obscurity here are blank rows and columns. So another example here, let me open up a workbook here, 916 kilobytes in size. Sorry, close this first. Okay, here is that workbook I just opened up. 916 kilobytes. What's in here? The answer is nothing. This workbook was derived by having a workbook that had some information in there before. I deleted everything, but if I hit Control End, the last cell that's in here is AH 53,150. So even though there is, again, literally nothing in this workbook, it's almost a megabyte in size. I go back to my workbook summary utility here. We have the used range. This is what Excel thinks the workbook contains. A1 to AH 53,150. And a compacted range. What actually is the extent of data in there, which is just cell A1, and there's nothing in A1. So this workbook is big just because there used to be data in there, but it's no longer really relevant. If you have a situation like this, you'll go to the end of the page and be like, go end of a workbook, you can kind of control it and be like, well, this doesn't make sense. There's nothing down here. And chances are you have these extra blank rows and columns that are in place. So let me just clean this up a bit. Close this real quick. Close this. Okay. So if I go ahead and let's see what's the best way to do this. Clear rows. You want to remove any unused rows and columns? Yep. Now if I do a save as, all this version 4. You'll notice that these scroll bars are now much, much smaller than they were before. They Control End. I'm in the same spot. Go ahead and save it. So our 916 kilobyte file is now, looks like 9 kilobytes, just removing those excess rows that were in there. They were just all blank. And the last one I want to mention here, again, this is really kind of obscure, but I've seen it happen enough that I wanted to call it out. Occasionally you'll have a workbook with macros in there that have been running great for years, no problems. And all of a sudden, they'll kind of start having issues. They'll give you some errors that really don't make a lot of sense. They'll stop running for no real reason. When you debug it and try and do your testing, it doesn't look like there are any issues that are in place there. This can be a result of what are called compilation artifacts in your VBA code. So when you go to an Excel file and you compile the code, it creates these artifacts in the background that are saved in the file. And those don't normally cause problems, but over time, like they never quite get cleaned up. So we keep compiling the code, keep running it. eventually can get some artifacts that really prevent the code from executing at all. When this happens, there is a way to get around it. The cleanest way is to export all your code modules, remove them from the workbook, and then re-import them. Go back to my cell here. So again, I have this add-in which helps you do that. There's a one called clean code, which will do exactly that. It will export all your modules, remove them from your source workbook, and then re-import them. So I found this to be a lifesaver because when this situation happens, there really isn't a good solution other than to do this. You can try going back to an older version of the file, but it probably still has at least some fairly arcane compilation artifacts in there that need to be cleaned up. So you're just delaying when it would happen again. Okay, so just for a summary here, the first thing I want to mention is I'm a huge fan of Excel. And while it seems like Excel really can do anything, we shouldn't ask it to do everything. Excel is a great tool for prototyping. It's a great tool for putting together charts, but it shouldn't be used when you have a whole bunch of data that you need to be processing. You should put that in a database. You shouldn't be using it if you have links to like 500 files that are being linked in your file. Maybe it's better then to look into a centralized database for that. If you're using volatile functions everywhere, I strongly recommend getting rid of those. I had a situation once where someone had a volatile function which was there strictly for presentation. It was just find the length, the width of this column, and put in enough x's so that it fills out the column. And that single function he had in there was copied over, 20 columns and slowed down working in the workbook by about like 95%. And of course, there's really no substitute for doing proper review and maintenance of your Excel workbooks to make sure that your performance is what it should be. Make sure you review your complex formulas, review your names. If there's any code that's in there, make sure you review that from time to time. And there really is also no substitute for doing appropriate documentation. If you must have these functions in there, if you must have a super huge workbook, if you must have worksheet level names, at least say why you're doing that. Not just, here it is, it's super big, but also it has to be big because it has to go to this group downstream, and they need to have an Excel file for this. I hope you've enjoyed my presentation here on making workbooks work. And with that, I will pause for any questions you might have. Thank you.